Today's topic is about graphing rational inequalities. In yesterday's video I did show you one graph so that you could see the connection between the graphical and algebraic methods for solving rational inequalities, but today's going to be exclusively about tables and graphs and how we find our solutions using tables and graphs. So let's take a look at number one in your student notes. You will need your graphing calculator because we need precise graphs to solve these visually using a graph. So make sure you have your calculator and enter the left side of number 1 into y1 and the right side into y2. So I want to make a note: when you are entering x divided by 4 minus x into your calculator, you need to put parentheses in the denominator. So x divided by open parentheses 4 minus x close parentheses should look just like this, because otherwise your calculator will see x divided by 4 and then it will subtract x. So make sure you've got your graph set up properly. When you go to your table, you should see these values from 0 to 6. Go ahead and fill those in on your student notes. And let's take a look at the graphs for these. So the rational part of it is the left side, and you can see the pattern that those points are making. I'm going to put the asymptotes here. If we look at our table, we know there's an asymptote where x equals 4. So we'll put that here. And then we can't see from this table where our horizontal asymptote is going to be, but we can see these are the same degree. So 1 over negative 1 is going to mean we have a horizontal asymptote at y equals negative 1. So just connecting these points, we have a graph that looks something like this. And on the right side, like this. And then that line, y equals 3, is just a horizontal line, and it will be right here. So when you're solving rational inequalities graphically, you are looking for any place where, if we look at this problem, where the first function is less than the second function. We can state that using our colors. We want to know where the blue function is less than the green function. So that happens here on the left side until we hit 3, and then on the right side from 4 to infinity. So the key points we are looking for are these intersection points and our asymptotes. The solution here is going to be negative infinity to 3. And note that this is going to be an open bracket because we are looking at less than, not less than or equal to, so we don't want that 3 to be included. Or this stretch from 4 to infinity. So looking at the table, if we want to find our vertical asymptotes and our intersection points, what are we looking for? What you want to look for are values where your x and y's are the same for both functions. So here 3, 3, 3, that's going to be our intersection point, and here 4, error 3, that error tells us there's a vertical asymptote. So these will be our boundary points, and what we need to look for is where our y1 values are less than our y2 values. So we can see that happens when x is 0, when x is 1, when x is 2, and when x is 3. And then again when x is 5, 6, and so forth. These are less than 3. If we were more precise with our values, we would see that from 3 to 4, our y1 values are greater than our y2 values. But that's what you're looking for on a table: your intersection points where all the values are the same, and your vertical asymptotes. That will help you figure out where your boundaries are and what your intervals should be. Number 2, Again, when you enter this in, make sure you put parentheses around your denominator for y1. When we graph these, let's look for our asymptotes. We're going to have vertical asymptote when x is 1. So right here. Our horizontal asymptote, this one is bigger on bottom, degree of 0 in the numerator, degree of 1 in the denominator, so y equals 0. Now we can graph this function. We have some points as well. I already plotted my points previously to not have to take the time to do it right now. Let's hit those points, hug the asymptotes, and we'll have a graph like this. Our intersection points, looking at the table, we can see that at 2, where x is 2, we have an intersection point because the y values are the same as well. So that occurs right here. Forgot to plot the right side, which is y equals x. This is just a linear function. And our graph will look like this. So again, there's that intersection point that we saw on the table. It occurs right there at 2, 2. So our solution is where the function on the left, the blue function, is less than the function on the right, the green function. So out here to the left, from negative infinity, we have another intersection point that I did not identify. That's here at negative 1, negative 1, negative 1. From negative infinity to negative 1, the blue function is greater than the green function because it's above it. So that's not part of our solution. But from negative 1 to 1, we have the blue function dropping below the green. From 1 to 2, the blue function is greater than the green. And from 2 to infinity, the blue function drops below again, so it's less than. So we can see that our intervals are going to be from negative 1 to 1 and from 2 to infinity. And again, we are dealing with just less than, not less than or equal to. So negative 1 to 1 or 2 to infinity. And that's our solution. Number 3, I want you to go ahead and do by yourself. Notice that in the numerator we have an x plus 5, so you need to put that in parentheses in your calculator, just like the denominator needs to be in parentheses with x plus 2. So make sure you input those correctly, insert your x and y values, draw your graph, and figure out the solution to the inequality. Moving on to number 4, this graph is a little bit more complicated, so to save some time I went ahead and plotted it already. On the left side, you need to be very careful putting this into your calculator. So your y1 value is going to be this whole thing on the left side. Put your numerator and your denominator in parentheses. And in the denominator, you're going to have a lot of parentheses because this whole thing needs to go in parentheses. And that should give you a proper plot. If your plot doesn't look like this, then you need to look at those parentheses. Something probably went wrong. So here we've got our x and y values. If we look on the table for intersection points, we can see there's one here at x is negative 2 because we have negative 2, 1 and negative 2, 1. So there's an intersection point when x is negative 2. Again, we have one here where x is 3 because we have 3, 1 and 3, 1. So when these y1 and y2 values line up, we've got intersection points. Looking at this graphically, we can see our intersection points are here and here. So we want to figure out where the function on the left is less than the function on the right. The function on the left is blue, the function on the right is green. So the function on the left, the blue function, is going to be less than the green when we are below this green line. So we can see here on the left that occurs from negative infinity to negative 3. It occurs again from negative 2 to positive 2. And then again from 3 to infinity. So we have a few different intervals we're going to need to write. Again, we're just dealing with less than. So we're going to have negative infinity to negative 3. Note that wherever you have a vertical asymptote, you will always have an open parentheses because that value will never be included. Here, because we are dealing with less than, our next interval will be negative 2. If it were less than or equal to that, intersection would be a closed bracket. So negative 2 to positive 2. Or finally, we can have 3 to infinity. So that's our solution for number 4. 5 and 6, I want you to complete on your own. So here they are. Number 6 has already been given to you graphically, so that one should be a little easier. You can do that fairly quickly. Bring those prepared in class tomorrow, and we will continue practicing solving rational inequalities using graphs.